Hello everyone, my name is Mark Voronenko. I'm a civil engineering tutor for VCA Student Success. Feel free to stop by Dana 152, get some help from tutors there. Check the the schedule that's online on the VCA website. You get to see what the tutor hours are and then come on their respective time. If that doesn't work, feel free to email Becky. Her email is on the website as well. You can find it there. Email her and we can work something out. Anyways, I'm going to cover some geotechnical engineering topics. For now, it's just going to be consolidation, um, because it's good to review these things. Now, let's start with the soil properties, right? Soil. Um, so soil in and of itself isn't purely, it's not a homogeneous material. It's a mixture, right? It's composed of these tiny little particles, right? At varying shapes and sizes. So what what does that do? Well, you know steel. Steel is a homogeneous material. It has a crystal structure. It's all connected, right? It's a homogeneous material. It's all connected. There's no voids in there. Soil has voids, and I've shaded voids here in blue, just to be precise, right? So soil is not a homogeneous material. It's a mixture. Um, that means that there are essentially two components contributing to soil structural integrity. So you have one, uh, the voids, and two, the actual mineral properties. So as you can see here, um, if you zoom in on a single particle, you can see that it's made of it's a mineral or composed of several types of minerals. And so the mineral skeleton, as we call it, um, is the backbone of the soil, and then the voids, depending how much there is, will affect the integrity of the soil. So, settlement, right? Settlement. What is settlement? As you can see here, uh, the if you have a chunk of soil, right? This is all soil, and I regret to have chosen this color because not now it's. Anyway, so if you put a load on soil, it's inevitably going to compress. Okay, and this difference, and I'm gonna choose a different color. Let's see. I'm just gonna go with red. So, as you can see here, this difference is otherwise known as settlement. Right? Now, settlement is there's different parts for settlement. So, settlement is we're gonna call this total settlement, and I'm still getting used to these styluses, so give me a break. Um, Settlement, you have three components. You have the immediate settlement, you have the consolidation settlement, which is what we're going to be talking about, and you got the secondary settlement. Okay, this is the immediate. So yes, I am getting better at this in these stylus. Compression, yeah, consolidation. So this consolidation. Okay, and then this is the secondary. Okay, so I'm going to redo this because this does not look like a T. So this is supposed to be a T. Cool. So the total settlement is equal to the sum of the other types of settlement. Cool. Um, so the immediate settlement, imagine, right? You're gonna put a load on the soil, right? The immediate settlement is just the response of the soil immediately, right? Kind of given the name. Secondary is time dependent, constant effective stress. So we don't really delve into that one in class. Now, consolidation, that's the one we're most concerned about because that one is time dependent, and we deal with it a lot, especially with clays, because um, how does consolidation work? Well, consolidation is, by definition, is the rate at which, or is the compression of the soil, which is dependent on the rate at which the water leaves the soil. So I'm actually going to use this um, this example that I've already drawn. Um, so let's say this is all water, right? So as you squeeze down on the soil, right, the soil is gonna originally be up here, right? And then once you squeeze down, you're gonna um, lose some voids, and then this soil is gonna become dense. Now, select that, cool. So once you apply a stress to it, the water is gonna leave. Okay, that's some water. Um, Now, that's what consolidation is. It's you pressing down on the soil, and the water is leaving the soil, and so are like voids like air. Um, Now, it consolidation is primarily dealt with clays because if you think about it, if you have gravel uh, or sand, they are um, they have more voids. They are bigger particle size than clay. Clay is very, very small particle size, as you can see here. Let's suppose that this is clay, okay, and you have voids trapped between the particles of clay, and you apply a load to this clay. It's gonna these voids are gonna have a hard time getting out because uh, they're surrounded by the clay particles. Whereas in the left example here, let's suppose that's sand. There's relatively uh, more space for them to slide through the particles and escape. Therefore, for sands and gravels and other large particle soils with large voids, the um, consolidation happens immediately. Or the voids are leave immediately. There is essentially no time for the compression to happen. Um, but on the contrary, with clay, like I just showed you here, clay is so fine, and the water gets trapped in there that it needs more time to get out. So, like if you've ever walked in mud, for instance, it depends on what the soil is for the mud. Let's say if it's kind of sandy mud. If you squish, if you just walk on the mud, right, you hear the squishing sound. That's the voids escaping the soil, and what's left behind is your footprint, that's the settlement. The settlement caused by your feet. Um, all right. Next thing is, so we've just talked about consolidation, what it is. Um, how does it exactly work in terms of stress? So, pretty much, right. You have to. Salt is a sponge. It contains the voids, contains water. If you squeeze a sponge out, if you squeeze a sponge, the water comes out. And obviously it depends on how hard you squeeze it. If you squeeze it very little water comes out. If you squeeze it more water comes out. You get the point. Um, However, this picture right here, the one below the sponge, is pumice, right? Pumice has voids too. And suppose that you use pumice as a sponge, it absorbs the water. If you try to crush pumice with your hands, right, it's going to be much harder to squeeze it than a sponge. So, the consolidation depends on the soil properties as well. Um, and the stress. So it's a consolidation is a stress, strain, and time phenomenon, meaning that it's dependent on the stress applied um, on the soil and the strain, which is related to the stress. So the strain on the soil, which is how much it deforms, um, and that is also proportional to how much voids um, escape the soil, and also time because it takes time for the particles here. So these particles, if you put a load of them, they're gonna rearrange. It's gonna take more time for clay, the fine particles to rearrange. So it's dependent on time. Now, I'm gonna explain it more in depth using this example out of the textbook. Um, so here they're using this spring analogy in a piston. So you can apply a load. I'm going to use a bigger marker. Maybe that one. Yes, I like that one. Okay, you can apply a load on. That's not big enough. Okay, that's slightly better. It's moderately adequate. There we go. So that you add some. For now, it's just going to be overburden stress. You're just the weight of the soil. Okay, and this here is the soil. And I'm like I said, I'm still getting used to the stylus, so it's not very professional. But that you get the idea. This container is just a soil sample, right? Obviously, like it's just captioned here is that's the water. It's just floating around in there, and then the spring itself is gonna be the soil skeleton because that's the backbone of the soil. It provides the structural support or structural integrity of the soil, the minerals that compose the soil. Okay, so right now nothing is happening. This is, I will call this, oh come on. Alright, we're going to call this um, nothing's happening. Phase 1, something like that. Nothing's happening here. There is no water squeezing out of the soil. Now when you put more load, as you can, as it shows, oh, come on, as it shows here, if you put more load on it, you got your original overburden stress, and then you got your delta SV or S, your delta S, which is the added stress. So now you have you have more load on the soil, and what happens here is there's going to be increased pore water pressure. Okay, increased pore water pressure um, right here, as it shows, and the water starts to come out. And I want this to be thicker so it will be visible, because otherwise there won't be any points. So water starts coming out. Now that you've reached a certain point where the pressure is enough for it to start squeezing out. We call this the consolidation pressure. So this point 2, this point 2 is we call it the consolidation pressure. The notation, if I recall, is just, if I can write for the life of me, right? It's just sigma C. That's the consolidation pressure. Okay. What can I write? Text. Okay, here we go. I'll just oops. Please, can I type? Uh, Scratch that. I'm just gonna figure that out later. So okay, remember, sigma c, consolidation pressure, that's the point where the um, water starts to escape, the voids start to escape the soil. The pressure is just enough for that to happen. That's a pre-consolidation stress or the consolidation stress. Same thing. Now, stage 3 is when consolidation has occurred, where the soil has compressed after some time. After some time, we get this uh, settlement. Okay. And that's it for now. Hopefully, I'm gonna just go over this real quick again. Um, so the reason why, let's say that this was just air, right? If this phase 1 here, there was no water inside. If you had stress on the soil, it's immediately going to respond because the only thing that's holding the soil together is the mineral structure itself. If it was just dry soil, it's going to rely on the mineral skeleton. Um, and then, um, but the reason why it does not do that when it has water is that the water takes on some of that stress too. And so it's not until the water gets has enough stress that it starts to escape, and once it escapes, then the soil starts to compress. All right, so that's part 1 of consolidation settlements, and I shall get to the next one shortly.